Now next up, what I would like to do is finish that hinge exercise by assembling it all together. Now, we probably need to design the pin that holds both the hinges together, and we shall do that in the master file here. I can go onto the front plane, create myself a pin, and this pin happens to be a circle that fits snugly in this space. So I'm going to, from origin to the edge here. At this point in time, I can make some decision on the tolerancing, etc. I'll leave some clearance in, but I'm happy with this approach for the purpose of this demonstration. So I can green tick to confirm. I don't need to dimension that because those are definitive points. However, it looks undefined, so I'm going to go ahead and please Solidworks by dropping a number there, which is 20. Exit the sketch. Now I can use this sketch to create a feature, but only thing I need to bear in mind is I do not wish to merge the results together, otherwise that will form one complete solid, which is not intended. So I'm going to go and say it's a mid-plane extent, and I would like that to be ideally same as this number here, which is equals to length. Green tick to confirm, and there we have it. I think we created another part within the master file right here. I can send that into a new part, hinge pin. Okay, excellent. I think I have everything I need to be able to assemble the hinge together now. I don't think I need the master file anymore. I'm going to head over to the assembly environment. Here, I'm going to start with something that forms the chassis of the hinging mechanism. And the way I see hinges moving, I can probably bring one of the parts in, stick a pin through it, and next part in, or maybe first part in, second part, and pin to hold it all together. What I would like to do is probably use one of these parts as my base part. I'm happy with that, the way it sits. Let's go ahead and bring the second part. Green tick to confirm. I'm going to go insert component, and I wish to bring in the second part at this point in time, which fits somewhere like so. Not going to worry too much about positioning just yet, because I know I can control that through the mates environment here. So I'm going to go leave that there. I know that's not the right position, but we're going to control that now. I'm going to go into mate. I'm going to make sure my blue box is active, and I don't really want to worry about selecting any of these. I'm in smart mates automatically, so I'm going to go and say, how about we actually align? So I'm going to select the inner space here, and I'm going to select the inner space along there, and that will actually align that or make it concentric, which is exactly what I needed. And green tick to confirm. Now next up, just to see how it functions, right? So it is articulating like so, which is pretty good. I wanted that motion there. However, there are some constraints, and there are some degrees of freedom I need to fix. Okay, and for that purpose, I'm probably going to make sure that this face aligns with this face here. It can be done through mates environment. I'm going to go clear that. Let's create this new mate here that aligns those together, coinciding. And I'm going to accept that by green ticking. That's exactly the relationship I needed. Let's have a look. It articulates pretty good. We have some issues here that two parts are going through each other, and this is when we need to set up limit for it to stop doing that. Okay. Finally, I'm going to bring in that pin we designed earlier. And this pin also needs to go through this space here, and for that purpose I'm going to actually align that. I don't need to select any of these relationship by default. Solidworks will make a suggestion, and generally I tend to go with those. Concentric, that is a pretty good choice for me. And whilst we are on the case, I'm going to make sure that this space is at the same level as that surface there all the time. So I'm going to accept that. Green tick to confirm. Let's give it a spin. That's pretty good. That's exactly what I wanted. That is fixed. As you can see that in the bracket, letter F. We have this articulating part, and we also have the pin which is allowed to rotate, and I'm happy with the overall assembly. Other things you can do is try and control the extent of this articulation. So if you want to stop that moving through that part, we'll have to limit that. So I'm going to go ahead and set myself a limit function between probably this edge and this edge here. Let's see what Solidworks gives us. So I'm going to go, when the blue box is active, select these edges, and I'm going to go into advanced mates. In advanced, I'm going to switch on the limit, angle limit, and it has come up with some random number, random angle. I think I would like to go with 160, which is pretty, it's not open all the way flat. However, that's a good good position for it to be in. My max can be 160. I'm okay with that. And my minimum, I'm going to go and say those two coming together, I'm going to leave a distance, an angle of 10 degrees between those. So I'm going to say that is 10. So that's minimum just by by looking at the icon. This is the maximum value right there, and this is our default value for the angle. I'm going to green tick and green tick again. I want to see how it functions now. I'm going to grab that. That stops there. That's pretty good. It's actually by accident I got it right, because that started to go through that part there. I probably need to look into opening that up a little bit more. There we go. And you may wonder, how do we do that? How do we know precisely when that starts to go through it? There is a mechanism in SolidWorks by which we can stop it from colliding, or maybe just when it starts to collide. Let's see if we can make it work now. This is going to give me an opportunity to show you a couple of other things. So what I wanted here is, I'm going to have to let that limit go in a minute, but let's leave it there, because that's going to give us a really nice new minimum angle. At the moment, my number of 10 degrees, it's not small enough, or it's actually it's too small. In fact, I want an angle which is somewhere like this. All we got to do is probably a combination of these things. There is this feature in SolidWorks that's called move component, and within move component we can do lots of different things. One of those things is to detect collision. So this is exactly what I'm going to do. I'm going to switch on move component, and I'm going to switch on collision detection. And what that really does is, as the parts start to go through each other, it will stop. It will obviously stop at the collision. It will make a sound. It will highlight the faces that are clicking together as well. So I'm going to go and do this. I'm going to leave it there, and what I would like to do now is use the evaluate tool, measure, and I would like to measure the angle between these two edges so I can use that angle in our limit. So I'm going to go select that line and select this line here, and I was hoping to get the angle which will be in the drop down menu. Didn't mean to select the face, so the face has got to go. Select that. Angle is 14.36 degrees. That's the answer I'm looking at. 10 was too small. 14.36 degrees was obtained using the evaluate and measure tool, which gives us that angle right there, 14.36. I'm going to remember that number. Right click, edit, and I would like to edit my 14.35. That is a good number right there. So I'm going to say 0.336. I would round it up because I want it to not collide. 14.35 would be the wrong choice. I'm going to go green tick to confirm. Confirm again, and I'm just going to make it go away by ticking green. All right, let's give that a good spin now. Stops there, 160 degrees, and that looks like it's stopping just before it starts to collide. So let's take a look from the side. Yeah, it looks pretty clean to me. It doesn't go through that profile right there. I like the way it wraps around and it keeps the contact, and it moves quite nice and smooth all the way through. This is a really good exercise. Just to summarize, if you wanted to change any of these relationships, you can go in there, right click, edit, like so. Or if you didn't want a part, you want to let it go, you can right click, delete, or you can replace that with and you can replace that with a new component if you like. Okay, I'm happy with this result. It looks pretty realistic. It is exactly what I was expecting for a hinge to function, and this kind of completes our hinge exercise at this point. Next up, I would like to assemble this dumbbell together. There is a bar, there's a rubber ring that goes all the way up to the plate and stops it from coming out. Obviously stops some noises as well, and we have this end piece here which allows you to thread it all together, and we got a couple of weights. Let's see if we can assemble this. Once again, I would like to start this assembly by bringing in the bar, which I think is the rock in this whole place. It allows the assembly around it, so it's only sensible to bring the bar in. Bar does not articulate itself in reality. It's the plates that are slid on it, and it's the end cap that is brought in together, and those are the moving parts, not the bar itself. So the bar comes in. The minute it gets here, it will fix itself to the origin, and then I'm now free to bring in more components. I'm going to go insert component, and probably at this point in time I would like to bring in one of the weights here. Okay, what I would like to do, once I confirm that, I'm going to go into mate command, and I would like to connect this face here with that. I'm going to accept that, green tick to confirm. Now we have partial success here because it has done literally that. However, that's not quite right. So to be able to fix it, I'm going to carry on saying, how about we make these concentric as well, and that kind of gives me the result I was after. There we go. It's allowed to spin here, which is pretty good. That's exactly what I wanted, for it to stay there. And if I wanted, I could carry on using the same methodology to bring in the weight on the other side. I would like to actually align those together, and I would like the plate to stop at that face. Green tick to confirm. Sometimes Solidworks will do this. And that's not what I was expecting. So by default, Solidworks will try and give you that. If that happens to you, make sure you can hit the flip icon, which gives you an alternative solution to the problem. So I'm going to flip that to the right way, and I'm going to go green tick to confirm. This is pretty good. Green tick to confirm. I'm going to bring in another component here, which is the 0.8 smaller plate. Once again, this would go in as standard. Actually align that here, green tick to confirm that. And what I would like to do is make sure that connects onto this. So when my smart mates is active, I'm going to go select this and select that and that is a pretty good resolution. I would like to bring in the next part. Let that go. Green tick to confirm, and I would like to make that not that way. It is still a solution though. It's allowed to do that, and I'm looking to stop that. How about making sure that face remains connected to this face here, and that is a very good solution. I like that. Next up, I would like to bring in the end piece. Which is this. Before I assemble this, there's also a rubber ring that goes into that lip there. So what I would like to do now is probably bring that rubber ring in too, and make sure the rubber ring goes in all the way in there. So I'm going to do a mini assembly right here. So that face is connected there, and I probably want to flip it now because I wanted that like so. Also, whilst I'm the case, I'm going to go say that and that are in a concentric relationship, and it gives me the result I'm after. Now then, I'm free to do whatever I would like to with this piece now. That's a mini assembly or sub assembly in this particular case, and I would like to align those like that. That's pretty good. Wrong position obviously, however I'll come out and go back in whenever I wish. Now what I would like to do is make sure the rubber is connected onto the inside of that, and that kind of gives me the correct version. It doesn't come out anymore, it stays there, it's allowed to spin. And also I'm going to repeat the process for the other side. I wonder if I can use something that's called a mirror relationship. There is no central plane, so I don't think I can use a mirror relationship in this case. So I'm going to have to do this manually. End piece, rubber ring, make sure they're connected, probably flip that, and also making sure they're actually aligned to each other, and that gives me a pretty good result. And as you've seen before, I'm going to go and actually align. Just use a smart mate. We don't need to worry about the relationship. Solidworks will pick something from the box. Now this is a classic situation where we need to flip. We got to use the flip option to create a different version of that solution. So I'm going to go, yes, that's the one I'm after. Green tick to confirm. And what I would like to do is make sure that is coincident onto that face right there. And I'm going to go green tick to confirm. I'm happy with this assembly. The parts are allowed to spin there, but they won't come out of the dumbbell. Okay, as you can see, the parts list is here, and the relationships are all contained within the mates folder, and we have a fair few of them now. Okay, anything you would like to edit, you have to head over to the left hand side space, delete or add more parts, or edit the relationships from here. That is the standard process now. Hope you like this.